Hi all. Today we are going to see a question from GATE 2019 Mechanical Paper 1. Question number 21. A solid cube of side 1 meter is kept at a room temperature of 32 degrees Celsius. The coefficient of linear thermal expansion of the cube material is given and its bulk modulus is given. So if the cube is constrained in all directions and heated uniformly to 42 degrees Celsius, what is the magnitude of mean volumetric stress in MPa induced because of heat? So if you want to check out more details about this kind of problems, you can see the NPTEL course Analysis of Strain 1 to 4 in Strength of Materials by S.K. Bhattacharya from IIT Kharagpur. So let's go forward and see how to solve this. So these are some of the useful data that we'll be using in this particular problem, where your thermal strain is of this functional form in as a function of coefficient of thermal expansion and change in temperature. And also these are the forms for volumetric strain and volumetric stress. So we'll see how did we arrive at this particular expression for volumetric strain shortly. So now before doing anything, let's see what is volumetric strain. So your volumetric strain is change in volume by its initial volume. Okay, so how do we derive this? So let's say you are having some box of dimension, let's say in this case we are having a cube. Okay, so its length in all direction is going to be, let's say it is A. So your initial volume is A cube, right? And now due to heating, what is going to happen? You will have some change in its dimension, right? So let's say change in A by A, that is the strain. So that strain is equal to alpha delta T, right? So if you look carefully, your change in that length can be written as this. So that means your new length, let's say it is A dash, that is equal to your original plus delta A, right? So which can be written as A into 1 plus delta T alpha. Okay, so now therefore your change in your volume, that is going to be your A dash cube minus A cube by divided by volume, so A cube. So now what you are going to get is your A cube into 1 plus alpha delta T whole cube minus A cube by A cube, right? So now if you solve it further, you're going to get 1 plus alpha delta T whole cube minus 1. So if you solve it, you're going to get further as 1 plus alpha delta T minus 1 into, so this is A cube minus B cube formula, so 1 plus alpha delta T whole square plus 1 into 1 plus alpha delta T plus 1 square, so that will be this. Now this will turn out to be 1 plus, again expanding this term, you will get 2 into alpha delta T plus alpha delta T square plus you're already having this term, so 2 plus alpha delta T. So if you solve this further, so let's take it from here. So you will get delta V by V is equal to alpha delta T into, so you have 1 plus 2, so that will be 3 plus 3 alpha delta T plus alpha delta T square. Okay, now again solving this, you will get 3 alpha delta T plus 3 into alpha delta T square plus alpha delta T whole cube. Now this formula that we are going to derive is for very finite strain, that is the strain is going to be very small. Okay, increment in the strain is going to be very small. So that means your terms with you know square cube for this particular case, because these are all strains, right? Your alpha delta t is actually the strain. So that means if it is going to have more than one power, we are going to consider it as to be very negligible as compared to this term. So that means these things are going to be taken as zero. So your mean volumetric strain or approximate volumetric strain is going to be 3 alpha delta t. So this is how you derive this formula. So you can arrive at this formula by other methods also, but anyway, let's use this further. So now we know that we are supposed to find what is the volumetric stress. So your volumetric stress, let's say sigma v, is it going to be your bulk modulus into your volumetric strain. Okay, so now let's use this volumetric strain. Again, we found it to be 3 into alpha delta t, right? So now we have to solve this. So what are we given here? Your bulk modulus, which is 200 GPa. So let's convert it into MPa. So 2 into 10 raised to 5 into 3 into alpha, which is 1 into 10 raised to minus 5 into change in temperature. So it is changing from 32 degrees Celsius to 42 degrees. So the change is again 10 degrees Celsius or 10 K. So now these two will neutralize. So finally we'll get is 60 MPa. So that is your volumetric strain. So this is your final answer. So you can see that it was a fairly simple problem. If you want to know more about this kind of problems, you can check out NPTEL lecture. However, this particular relation that we derived was the important aspect in this particular case, and I hope you understood this problem. So thank you.